Installing Gastite flexible gas piping is fast, easy, and simple. Hi, and welcome to the Gastite installation training video. In keeping with our high standards of quality and our ongoing efforts to make Gastite as easy as possible to work with, we prepared this step-by-step video that will show you how to get consistent professional results every time you install Gastite flexible gas piping. Now, while every attempt has been made to cover the information you'll need to ensure the proper installation of the Gastite system, this training video has been designed to be used in conjunction with the Gastite design and installation guide and hands-on training. It is important to know that the installation of the Gastite flexible gas piping system must be performed by a qualified installer who has successfully completed the Gastite training program. The installer must also acquire all the necessary qualifications, licenses, and training required by the local jurisdiction where the gas piping is to be installed. Let's get started. Corrugated stainless steel tubing, also known as CSST, is the only complete fuel gas piping system that is designed certified by both the American Gas Association and the Canadian Gas Association. The Gastite flexible gas piping system offers many attractive features and benefits that provide significant advantages over conventional piping materials. Unlike rigid pipe, there's no heavy lifting, measuring, cutting, or threading. And with Gastite, there's no special flaring tools, soldering, or brazing typically associated with copper tubing or pipe. Imagine 250 feet of pipe that weighs only 38 pounds. A reel of tubing can be easily stored, transported, and handled. That's Gastite. Gastite is pulled through the building structure in a similar fashion to electrical conduit, and therefore requires different handling and installation techniques than rigid pipe or copper tubing. With Gastite, there are no special tools required. A standard tubing cutter and regular hand tools are all you'll need for a quick and easy installation. Gastite flexible gas piping must be installed in accordance with the most current edition of the American National Standard for Fuel Gas Piping using corrugated stainless steel tubing, ANSI IAS LC1. Gastite flexible gas piping is designed, tested, and certified by the laboratories of the International Approval Services. Gastite is a fuel gas piping material which can be installed under model building codes throughout the United States and Canada. The techniques outlined within this video are recommended practice for generic applications, and while every effort has been made to prepare this video in accordance with regional model codes in effect during its filming, it's the ultimate responsibility of the installer to determine local code acceptance. Should this video conflict with local codes will always take precedence unless, of course, a variance is obtained from the local administrative authority. Your Gastite representative and Gastite engineering support are available to help you should you have questions pertaining to code acceptance. Gastite CSST supplies natural gas or liquefied petroleum to appliances such as furnaces, boilers, water heaters, stoves, fireplaces, and barbecues. The XR series straight fittings are used to connect the flexible gas piping to distribution manifolds and appliances. Steel stub-outs and termination fittings provide a fixed point for attachment to movable appliances and utility meter sets. Hardened plates and steel sleeving are used to protect the tubing from potential puncture threats when the tubing is routed through studs, joists, and other structural members. Pressure regulators are typically used to reduce elevated gas pressure to appliance inlet pressure requirements. Multi-port manifolds provide a central distribution center for individual runs to each appliance. Shut-off valves and quick disconnects are used to control gas flow to the system and to individual appliances. Brackets for termination fittings, manifolds, and meter stub-outs allow for easy installation of system components. Manifold boxes, also called gas load centers, provide a clean and more polished look to manifold installations. Prior to piping installation, you should always refer to building plans or prepare a sketch showing the various location of appliances, the appliance load demands, the location of the gas meter or second stage LP regulator, and possible piping routes. Gastite has provided a worksheet in the design and installation guide that allows you to plan and design the installation of the Gastite piping system. Always refer to the Gastite Design and Installation Guide for reference data on proper system sizing. The included tables will provide technical specifications on gas pressures, energy content, and specific gravity for natural gas and liquefied petroleum. Depending on the installation requirements, Gastite CSST may be routed in a series arrangement similar in fashion to rigid pipe. Gastite may also be installed in a parallel arrangement in which appliance runs stem from a centrally located distribution manifold fed by a single run from the gas supply service. Since the first step is to determine your material requirements, let's begin sizing with a series system example. The series system is the most common piping arrangement utilized for rigid pipe systems and low pressure. This system usually consists of a main run or header with T's branching off to each appliance. This type of piping arrangement typically requires less piping material and more fittings, resulting in larger pipe diameters for the overall system. This is a typical single-family installation with 3 appliances using natural gas. The utility company's supply pressure, downstream of the meter, is 6 inches water column, considered low pressure. The designated pressure drop across the overall length from the meter to the furthest appliance is 1/2 inch water column pressure. Therefore, under total load, the most remote appliance will have a minimum 5.5 inches water column pressure. For this exercise and all other examples in this video, we will be using 0.60 specific gravity natural gas with an energy content of 1 cubic foot per hour, which is equal to 1,000 BTUs. To size run A, you must consider the total load of all the appliances and the total pressure drop from the meter to the furthest appliance, in this case, the dryer. So the total load here is 80 plus 36 plus 28, or 144 cubic feet per hour. To determine the longest run, you must add all lengths of pipe delivering gas from the meter to the furthest appliance, in this case the dryer, which is a total of 60 feet. Then refer to the sizing table for 6-inch supply pressure and 1/2 inch pressure drop located in the Gastite Design Guide. Under the 60-foot column, we find that 1-inch CSST has a capacity of 169 cubic feet per hour. Therefore, run A is sized using 1-inch CSST. Remember, when referring to sizing tables, always make sure the capacity of the pipe being sized is equal to or greater than the required load. To size run B, you must supply gas to the water heater and dryer only. The total load here is 64 cubic feet per hour. Using the longest run, the length is still 60 feet. Again, referring to the sizing table under the 60-foot column, we find that 3/4 inch CSST is the appropriate size, since it has a capacity of 68 cubic feet per hour. To size run C, you must supply gas to the dryer only. The total load here is 28 cubic feet per hour. Since the dryer is the furthest appliance, the length is still 60 feet. Again, referring to the sizing table, under the 60-foot column, we find that 1/2 inch CSST has a capacity of 34 cubic feet per hour, enough to size run C. For run D, you must supply gas to the furnace. The total load here is 80 cubic feet per hour. The longest run in this example is the distance from the meter to the furnace only, which is 20 plus 10, or 30 feet. Referring to the sizing table under the 30-foot column, we find that 3/4 inch CSST has a capacity of 96 cubic feet per hour, more than adequate to supply the furnace. And finally, run E is sized using the same method. Simply add the lengths of pipe back to the meter for this appliance and refer to the table for the particular load. In a parallel system, a main run from the meter supplies a centrally located distribution manifold. From this manifold, individual runs provide service to each appliance. A parallel system is most likely to be used with 14 inches water column or less, and will use more of a smaller piping material and less fittings for the overall system. For this exercise, we have used the appliances from the previous example and have added a range oven. The supply pressure, downstream of the meter, is 14-inch water column. The designated pressure drop across the overall length from the meter to the furthest appliance is 6 inches water column. Therefore, under full load, the most remote appliance will have a minimum of 8 inches water column pressure. To size run A, you must consider the load of all the appliances and the total pressure drop from the meter to the furthest appliance, in this case the range. The total load is 80 plus 36 plus 28 plus 52, or 196 cubic feet per hour. Using the longest run method, the length is 20 plus 35, or 55 feet. For this installation, you must refer to the sizing table with a 14-inch water column supply pressure and a 6-inch water column pressure drop, once again located in the Gastite design guide. Referring to the 60-foot column, since there is no 55-foot column, we find that 3/4-inch CSST has a capacity of 248 cubic feet per hour. Since that value is greater than 196 cubic feet per hour, 3/4-inch CSST is the appropriate size for this run. To size run B, you must supply the furnace load of 80 cubic feet per hour. Using the longest run method again, the distance from the meter to the furnace is 20 plus 10, or 30 feet. Under the 30-foot column, we find that 1/2-inch CSST has a capacity of 176 cubic feet per hour, well over the 80 cubic feet per hour needed. And finally, runs C, D, and E are sized using the same method. Simply add the lengths of pipe back to the meter for each appliance and refer to the table for the particular load. Let's now size a dual pressure system. As you'll see, this is the easiest of the three systems to design and size. The design of a dual pressure system incorporates two operating pressures downstream from the meter. It is identical to the parallel system with a manifold. However, in this type of system, the main trunk supplies elevated pressure in excess of 14 inches water column to a pounds to inches regulator. This pressure regulator then reduces the gas pressure to appliance inlet requirements. Therefore, you'll be referring to two separate sizing tables when sizing the gas piping. One table for the elevated pressure side before the regulator, and another for the low pressure side downstream of the regulator. Unlike the systems we've already discussed, in a dual pressure system, each run is sized for its individual length and load. This type of system offers the contractor the most flexibility in designing a system to satisfy appliance load demands while significantly reducing pipe diameters. Let's get started. For this exercise, we will use the appliance layout and load demands from the previous example. The supply pressure downstream of the meter is 2 pounds per square inch. The designated pressure drop across the overall length from the meter to the regulator inlet is 1 psi. Under full load, there will be 1 psi remaining at the regulator inlet. The outlet pressure of the regulator is 8 inches water column, and the runs downstream of the regulator are sized for 3 inches water column pressure drop. This will result in a minimum of 5 inches water column inlet pressure to each appliance. Run A from the meter to the regulator inlet will carry the total load of the system, in this case 196 cubic feet per hour. This run is sized using an elevated pressure table. The length of run A is 20 feet. For this run only, you should refer to the table for 2 psi supply pressure and a 1 psi pressure drop. Under the 20-foot column, we find that 1/2-inch CSST has a capacity of 398 cubic feet per hour, and therefore is the appropriate choice. To allow for the addition of future appliances, Gastite recommends the use of at least 1/2-inch CSST for main trunk runs. For all runs on the outlet side of the regulator, refer to the table with an 8-inch water column pressure and a 3-inch water column pressure drop. So, to size run B with a load of 80 cubic feet per hour and a length of 10 feet, 3/8-inch CSST is the appropriate choice to supply the furnace. As you can see, with a dual pressure system, sizing runs for their individual length and load is quite easy. Runs C, D, and E are sized in exactly the same fashion. For any additions to the trunk or appliance runs stemming off in a series type arrangement, sizing for these lengths of pipe should be performed using the longest run method. Now that we've designed and sized our gas piping system, let's cover some basic guidelines for the handling and installation of Gastite flexible gas piping. It's important to always store the tubing in a clean, dry place. This helps to protect the tubing from dirt, rain, and, yes, even pesky little creatures looking for a home. Capping or taping the ends helps to prevent construction debris from getting inside the tubing during the installation. Now, as with all gas piping, corrugated stainless steel tubing should never be used for grounding. For this requirement, use other code-approved grounding points. The Gastite tubing is manufactured with a plastic jacket that allows for necessary marking, ease of routing, and protection from potentially corrosive materials. Therefore, it should remain intact as much as practical for the given application. Any contact with chemicals containing chlorides, such as fluxes used to solder copper or acid-based masonry cleaners, should be followed by a thorough rinse and wipe dry. Gastite CSST is typically routed in areas that are out of the way of tradesmen and minimize the need for support. But when the installation requires drilling through a structural member, the drill hole must be 1/2 inch larger than the outer diameter of the tubing. When support is required, hangers and straps that are suitable for the size and weight of the tubing should be used. Metal straps are recommended for durability. Installing Gastite flexible tubing couldn't be easier. Gastite CSST may be routed beneath floors and alongside floor and ceiling joists. Due consideration must be given to future construction possibilities. For slab-on-grade construction where there is no basement or crawl space, the Gastite CSST should be routed on top of ceiling joists and inside vertical hollow wall cavities. Where the gas piping must be routed through the concrete slab, always route the tubing through a non-metallic, watertight conduit such as PVC or ABS pipe. For ease of installation, the inside diameter of the conduit should be 1/2 inch larger than the outer diameter of the tubing, and no fittings are permitted within this conduit. Sleeving requirements must also be observed when routing CSST underground outdoors, for instance, to a pool heater. All ends of conduit located outdoors must be sealed to prevent water from entering. Consult the Gastite design guide pertaining to various methods for terminating the end of the Gastite tubing in a conduit. When connecting to meters that depend on the service supply line or the house piping for support, the meter must be connected to a rigid Gastite termination fitting, a meter stub-out kit, or black pipe components. For meters that have independent support bracing and do not rely on the house piping for support, Gastite CSST can be connected directly to the meter. The XR fitting with the jacket lock feature will ensure there is no exposed stainless steel outdoors. This is especially important where acid is used to wash masonry. Gastite CSST may be connected directly to non-movable appliances such as water heaters, furnaces, boilers, and island cooktops without the need for a termination outlet or a flexible appliance connector. For movable appliances such as dryers and ranges, the Gastite CSST must be terminated to a rigid point on the wall or floor. From this point, simply attach a flexible appliance connector to the movable appliance. Remember to observe all requirements for drip legs and shutoff valves. It is important to know that the Gastite mechanical fittings have been tested and listed for concealed use. This allows the fittings to be used for attachment to fireplace key valves, branch runs using T-fittings, length splices with couplings, and meter and appliance stub-outs. Gastite tubing may be used to deliver gas directly to the ornamental insert of decorative and heat-generating fireplaces. However, Gastite CSST should not be used inside the fireplace for log lighters where wood logs will be burned due to the potential for physical harm to the tubing. For this type of construction, portions of piping routed into the firebox must be hard piped. The plastic jacket on the Gastite tubing has an ASTM rating for flame spread and smoke density, which meets typical requirements for routing through air plenums, drop ceilings, and similar building construction. Therefore, it should remain intact as much as possible. For more specific installation requirements pertaining to fire-rated wall construction and gas fireplace options, consult the Gastite Design and Installation Guide. Next, we move on to distribution manifolds. Manifolds are installed where multiple runs are made from a common location in a parallel arrangement. Manifolds can be manufactured from a one-piece iron casting, welded steel subcomponents, or an assembly of approved malleable iron tees and nipples. The location of the manifold is usually dictated by the size and design of the building structure, the appliance load and location, and the available gas supply service. A manifold may be mounted in an attic, garage, or crawl space, on the surface of interior walls, within a wall partition, or inside an enclosure box. Pressure regulators are required to reduce gas pressures in excess of 14 inches water column down to appliance use levels. The regulators specified for use with the Gastite system are designed to reduce 2 to 5 psi supply pressure down to 8 inches water column natural gas and 11 inches water column for LP gas. The regulator should be installed in an accessible location with an approved shutoff valve on the inlet side and, if required by local code, a union on the outlet side. These regulators are suitable for multi-poise mounting. However, when using a vent-limiting orifice, the regulator must be mounted in a horizontal upright position. When pressure testing the system, do not leak test the vent-limiting orifice with a liquid test solution. The regulators supplied with the Gastite system are suitable for outdoor use. However, there are several factors to consider for outdoor installations. To minimize the potential for moisture condensation and freezing problems in or around the vent port, the vent-limiting orifice must be removed. The open port must then face down or be covered to prevent water and foreign material from causing blockage. Corrugated stainless steel tubing is typically routed in locations that help to minimize interference from tradesmen and the homeowner. Concealed Gastite tubing should be routed in areas that will minimize the opportunity for physical damage or installed in areas where the tubing will be free to move to avoid a potential puncture threat. In areas where the tubing may be exposed to potential puncture threats and it is not free to move, steel sleeving and hardened steel plates are used to protect the tubing. The following 3 conditions must exist to determine the need for mechanical strike protection. The tubing is concealed by walls and structural members. The tubing is constrained and is not free to avoid puncture threats. And the tubing is routed in locations that are within 3 inches of potential puncture threats, such as drills, screws, or nails. The preferred method of strike protection is approved hardened steel striker plates. These plates are much more robust and Rockwell hardened to prevent nails and screws from penetrating, unlike nail plates used for copper tubing and plastic pipe systems. Approved plates are used to protect the tubing when it is typically routed through structural members such as ceiling joists, floor joists, and wall framing. Where strike protection is required, but hardened steel striker plates cannot be easily installed, strip-wound steel conduit may be used to protect the tubing. The steel conduit is typically used behind termination points and on tubing routed behind the renovation of existing walls. Now that we've installed the tubing, it's time to connect the fittings to the system. Gastite's patent-pending fitting includes fully reusable components and an exclusive self-guiding assembly that ensures a perfectly even flare every time. The toolless fitting features a metal-to-metal seal, so there's no gaskets, O-rings, or tiny split rings. Gastite's patent-pending jacket lock design locks the jacket in place so there is no exposed stainless steel beyond the nut, creating an integral jacket-to-fitting assembly not found with other systems. This makes Gastite the best corrosive-resistant fitting-to-pipe assembly for use in flexible gas piping applications. Gastite flexible gas piping is designed to work as a system. Therefore, only the components provided or specified by Gastite are to be used in the installation. Use of components from other CSST systems is strictly prohibited and may result in poor system performance. First, with a standard tubing cutter, make a cut on a straight length of tubing centered between 2 corrugations. Use light roller pressure and extra rotations in one direction to leave the tubing round and free of burrs. Using a utility knife, strip the plastic jacket back to the valley of the second corrugation. By removing only the required amount of the plastic jacket and no more, you're able to take full advantage of the jacket lock feature to produce a polished, professional-looking installation. One word of caution though, be careful with the end of the tubing because it is now very sharp. With the fitting body threaded into the gas appliance or manifold, slide the nut over the tubing. Next, separate the bushing by pulling the two halves apart. These are supplied together for ease of handling. Place the bushing halves onto the tubing and jacket as shown, ensuring that there is one corrugation between the end of the bushing and the tubing end. At this point, the bushings will begin to lock the jacket for a contaminant-resistant seal. Next, insert the bushings into the fitting body as shown. Notice that no pipe dope or thread sealant is required here. Now, slide the nut over the bushings and thread it onto the fitting body. Continue wrenching the nut to compress the last corrugation into the sealing surface. At this point, wrenching resistance will begin to increase. To make the wrenching process easy and prevent the tubing from turning on the sealing surface, it's important to remember to rotate the nut and not the fitting adapter body. From here, wrench the nut 2 hex flats more and you're done. Simple as that. The Gastite termination fitting provides a fixed point stub out for connection to movable appliances such as a range or a dryer. As you'll see, assembly of the Gastite termination fitting is similar in fashion to the XR fitting. First, with the mounting flange over the tubing, attach the brass mechanical fitting as previously illustrated. Next, thread the mounting flange onto the fitting. Use care when tightening the flange as you do not want to twist the tubing. Finally, secure the termination assembly in place. Should you need to extend the Gastite flexible tubing, there are several ways to accomplish this. A coupling designed by Gastite may be used to join 2 lengths of tubing. To connect CSST systems from different manufacturers, simply thread each manufacturer's fitting into a rigid pipe coupling. The installed Gastite system must be pressure tested during rough construction of the facility before the interior walls are finished. This will permit a more complete inspection of the piping system. The final installation must be inspected and tested for leaks in accordance with all local codes. In the absence of local codes, pressure tests should be performed in accordance with the latest edition of the National Fuel Gas Code or the Canadian Installation Codes, typically 1.5 times the maximum working pressure, but not less than 3 psi. For elevated pressure systems in excess of 14 inches water column, the Gastite tubing can be pressure tested up to 200 pounds per square inch if required. An elevated pressure system usually requires a pressure test of 10 psi or greater, depending on the local code. In this case, the regulator must be removed or isolated prior to pressure testing to avoid damage to the regulator and to ensure a complete test throughout the system. Pressure testing may be performed as a one-part test by replacing the regulator with a suitable jumper pipe length for testing the entire system. After the pressure test, the regulator is reinstalled and the remaining connections are tested for leaks with a chloride-free bubble solution. A two-part test can be performed by isolating the regulator from the pressure test with approved shutoff valves. For this method, pressure is applied to piping on both sides of the regulator. Upon successful completion of the test, the shutoff valves are simply opened. Remember, for a two-part test, it's important to close both gas shutoff valves to avoid damage to the regulator. Also, all termination points throughout the system should be capped and all shutoff valves connected to an appliance should be in the off position to prevent damage to the appliance controls. To make the final inspection a breeze, Gastite has provided a CSST installation checklist covering the most important aspects of the installed system. Installing the Gastite system is that simple. Follow these procedures and you'll get a clean, professional installation every time. We hope this video has answered any questions you may have about installing Gastite flexible gas piping. For help with larger or more complex jobs, or if you have any questions, you can call Gastite Technical Support at 1-800-662-0208. Gastite, the first name in flexible gas piping.